Hello, everyone. Good afternoon, and welcome to our next edition of the Enterprise Big Data webinar series. My name is Jan-Willem Middelburg, and I'm going to be your host for this afternoon. And this afternoon, we're going to talk together around a very interesting topic in the world of data science, and that is how to leverage data sets which can be collected from the internet. Typically open data sets governed by organizations or by governments. So in this webinar, we're gonna dive into some of the details and present you with an overview on how you could use all of that in practice. Like similar webinars before, let me do a very brief introduction at first before we continue and discuss the actual topic itself. Before we get started, let me take a very brief moment to introduce myself, especially for those of you for whom it's the first time to join today. My name is Jan-Willem Middelburg, and I am responsible for the creation of the Enterprise Big Data Framework. I'm responsible for the exam and academic integrity of all the exams worldwide, and I'm the author of the framework itself. So I'm very excited to be with you here today and to explain a little bit around how we can leverage data in real life kind of use cases. If you want to get in touch with me after this session today, on the left-hand side of the slide, you will see all of my contact details. So you can always reach out to me on LinkedIn, you can drop me an email, or if you want to listen to more knowledge around enterprise big data, you can subscribe to the podcast. For everyone joining today and wanting to be hosted on the podcast, that's also an open invitation because I'm always looking for people with a lot of knowledge within the data domain. Good. So what do I have in store for you today? Very similar to some of the previous webinar series, I've divided this session today into three main topics. First of all, I'm going to place data ingestion into the context of the Enterprise Big Data Framework. We'll do a very brief overview of where to place it from a framework perspective so that everyone who's joining is on the same page on how you should read it. After that, I'm going to jump into the main topic of today, which is data ingestion. And I'm going to showcase you some of the basics of data ingestion and especially how you can leverage large data sets, which are typically available online and in most cases also available for free. And then after that, as most of you know, I'm always a big fan of showcasing how it actually works in practice. So after this, I have prepared the lab for you, very similar to some of the previous webinars. We're going to be taking a step-by-step approach to run through some of the online data sets. And I will show you how with a very limited and simple number of commands, you can get access and insights towards data which is publicly available. So three main topics that we're going to cover today. And this is what we will be covering in the next half hour, 45 minutes. Also an open invitation, as always, use the chat, use the Q&A box, which you see on the left-hand side of the screen. I'm always very happy to answer questions, or if you think I'm going too fast or you would like to have additional information around a specific topic or specific query, then by all means, feel free to ask questions. That makes attending a live demo and a live webinar much better on a day-to-day basis. Good, let's get started and dive right into it. So first part is where should you place this and what is the Enterprise Big Data Framework for those of you who are not familiar with yet. So as you can see here on the screen, the Enterprise Big Data Framework Alliance is an independent body of knowledge for the development and advancement of big data best practices. With our alliance, we're trying to professionalize the world of big data, and we're specifically trying to inspire, promote, and develop excellence in big data best practices. And a large component of that has everything to do with knowledge sharing, and knowing how you can translate data which is available into something that delivers value. So that's what we're going to be looking at. In order to streamline that, over the years, we've created the Enterprise Big Data Framework Alliance, and together with APMG, a certification scheme around that, so that we have a consistent way of spreading the word and making sure that people become more familiar with data-driven approaches and data-driven practices. On the top or bottom right of this slide, you will see the actual framework itself. So in a nutshell, because there's many webinars that I've given about this before, there are 6 critical capabilities within the framework, and the framework itself provides a step-by-step approach through which organizations can become more data-driven. So if you want to learn more about it, or you would like to get started with utilizing the framework, I strongly encourage you to download the resources. You see the resources in the top right corner, and note that all of these resources and books are available free of charge, so you can download the materials after the session today and read up on different topics related towards big data. Not surprisingly, some of the main things I'm going to cover today are also coming out of the books, because we kind of try to keep that as a red thread for the webinar series that we're hosting this year. Good. So what are we going to talk about? So in this session of webinars, we are going through the data analysis process. And in the sessions that I've been providing so far, and the sessions which have been planned for future, every time we are trying to cover a different topic out of the enterprise big data analysis process. And what we're going to be focusing on today is ingestion, because before you can do anything with data, before you have the ability to process it or to clean it up or to extract any relevant insights, you first need to get access to it. So today's session is going to be completely focused around data ingestion, which basically means getting data into your applications and systems in order to start processing it. As you can see in the middle of this slide, generally speaking, ingestion is either done locally from local data sets. It can be done online by leveraging data which is available through a network, and it can be done through connecting to databases. So the main focus for today is obviously going to be around the online data ingestion, and I will specifically focus around how you build connections to online resources. Local ingestion is relatively straightforward and simple, so we're not going to spend too much time around that. And for databases, you need proprietary connections in most cases. So for that reason, I've also excluded that for the session today. So that's going to be the main focus, and I always think it's good to start with painting the bigger picture so that you have a good overview of where do you place the content of the session today. Good, let's get started. So the second main part of this session is where we're really going to dive into a bit more detail. And as I've always been saying in some of the previous sessions as well, unfortunately, you cannot do big data or data science without having some fundamental knowledge. So in this second session, I'm going to introduce some very foundational concepts when it comes towards data ingestion. And we're going to be looking at different data types, the way data can be ingested into different systems. And we're going to be looking at what the implication will be of those different data types towards your ingestion techniques. After this session, we will then look at the practical components, and we'll start looking at the lab, where we will show you some practical demonstrations. Good, let's get started with a very central question, and that is, of course, what do we mean with data ingestion? Data ingestion, as the name suggests, is an activity which does ingestion, and which literally means getting it into a system. From an implementation point of view, data ingestion is a process in which data is moved from one or more sources to a destination where it can be stored and further analyzed. And the difficult part around these kinds of processes is that they are literally residing in different locations. Those different locations will help us to understand the different types of databases and different sources where they are coming from. Data ingestion is frequently used to create what is known as a data lake. So that is the central part that we're trying to structure and set up in order to make sure that we get all the data that we need together. So before we move any further, let me very briefly explain what a data lake is. In organizations, and especially larger organizations, a data lake is a centralized repository that allows you to store all your structured and unstructured data. And by doing this, we can start to look at how we can use that data at a particular skill. So by doing this, we can move and start populating dashboards. We can start to create visualizations, and we can make sure that we do these kinds of things real time. It's important to know this because within a data lake, what we're generally storing is a combination of structured and unstructured data. And that's going to have a very significant impact to the way that we ingest data in the first place. And in order to dive into that a little bit more in detail, it's important to start understanding the what kind of source you are ingesting data into. And the main difference that most enterprise organizations are dealing with is either a data warehouse or a data lake. So depending on the requirements, organizations will generally have either data warehouses or data lakes available. And this matters from an ingestion point of view because you would need to convert the data into the format which the data warehouse or the data lake can work with. So what's the difference between the two? So very simply stated, a data warehouse is a database which is optimized to specifically look at relational data within an enterprise. So it's typically dealing with data that can be neatly stored into rows and columns. And therefore, it has an SQL-like structure, if you know, if you're familiar with data structures. Data lakes, on the other hand, are primarily focused around unstructured data. And it stores non-relational data, typically from mobile apps, IoT devices, and social media, into a format that is more difficult to query and at least does not have the relational structure that we typically see in a data warehouse. In today's session and in today's webinar, I'm going to focus mostly around some structured data sets and some semi-structured data sets because we would like to analyze some key components of those data sets. And we would like to make sure that we have the ability to very quickly see some results out of that. But it's very important always from the start to really consider what the source of your data is going to be, and especially to what kind of environment you're going to be ingesting your data to. So that's a main reason why this is important. From a summary point of view, so let's very quickly summarize what we've just seen. Note that there is a very significant difference between data warehouses and data lakes, and whereas the first one is very much focused towards keeping relational or transactional data, the data lake, on the other hand, focuses on non-relational data, which is typically not stored in tabular formats. Most organizations that I've worked with are in the process of either moving from a data warehouse towards some form of a data lake. So the one on the right is becoming more and more important every single day. Good. Let's, now that we know a little bit around the difference of the source system itself, let's next look at some common data types, because in the demo that I've prepared for you today, we're going to be looking at some more common data ingestion techniques. And it matters a great deal to understand what type of data we are looking at. So the most common data structures that are commonly ingested are the ones that you see in front of you on the screen. Most common format is obviously structured data, which is data that neatly fits into rows and columns. The unstructured data that I talked about in the data lake has everything to do with data that does not fit into a predefined data model. There is, however, also a data structure which is somewhere in between, and we generally refer to this as semi-structured data. The reason that I've included this in today's session is that we will also very briefly look at how do you import semi-structured data from the web. And this is something that I would like you to particularly note about, because a lot of data sets that specifically reside online and which are made available through APIs have a semi-structured format. You can already see in the picture here that we're mainly going to focus around XML and JSON data. So a little bit later today, I'm going to have some slides that explain what that is and why you should know about this in order to deal effectively with data that you extract from the web. The fourth common data type, which is technically not a separate data type, is metadata. And that is used in order to kind of ensure that we give additional meaning towards unstructured data sets. Good. So now that you know a little bit around that, let's see why that's important. It's always important that you have these concepts clear upfront, because as soon as you would like to deal with or ingest data from any online data source, key questions are whether it's going to be residing in a data warehouse or in a data lake, and additionally, what the type of data format is going to be. And why that's important, we're going to see right now, and we're going to look especially at how do you read these online data sets into your environment. And the main reason that we're going to talk about this is that a lot of information that is potentially valuable for any organization is available online. These data sets can be publicly available. They can be behind a payment gate so that you only have access as soon as you have a subscription, or they can be available and providing specific trends around what people are saying, thinking, or doing online. Think about news articles. Think about opinions that people express on social media. Think about stock market information and the prices of commodities. A lot of those data sets are available online and can be used typically under certain conditions. To obtain latest information, you can potentially get a lot of advantage out of this if you could leverage that information on a time-bound and very quick decision-making. So will not be surprising that one of the main case studies here is whether it's possible to use public data sets in order to kind of see some kind of stock market tracking kind of system. So for that reason, it's very, very important to start leveraging and thinking about how those online data sets can be used in order to make more effective business decisions. So whereas the more traditional data analysis is more focused around internal data sets or data sets which are available within your own organization, you're starting to see that more and more organizations are now also including external or online data sets in their analysis. And many people think that that's very difficult, but I will show you today in the lab that that is actually quite straightforward if you know what you need to do. So what we are going to discuss today is we're going to start with some very basic operations, and that has everything to do with periodically downloading data from a specific source, and then by using XML or JSON data formats, being able to ingest that into a system so that you can make analysis. The data set that I've selected for today is relatively static. So it's sitting on a website and it's not being refreshed. But for the sake of the example today, I wanted to make sure that you understand how to retrieve it. And if data is refreshed periodically, the methodology will be exactly the same. It's just that you would need to have a timer to or a clock to periodically download this. So that's the benefit of data. What most people don't realize is that a lot of very good, very valid, and potentially very valuable data sets are available online. And in many cases, they are also free of charge. I've listed two examples here on the slide. One is from the government of Singapore, which has a very advanced, I would say, open data platform, and you can retrieve all kinds of government information with regards to education, society, the environment, and even the amount of taxes that is being collected. And if you go to the website and you type in your browser data.gov.sing, then you will be very quickly redirected to this data platform where you can download all these data sources. On the right-hand side of the screen, you see the equivalent, but then from the UK, and also contains a very significant amount of information that is all available and publicly open, and which organizations could use in order to make their own analysis or to augment their own internal data sets. So the main message and the reason why I'm showing this slide is to make you realize that there is actually quite a lot of value in data, which is publicly available and in most cases free of charge. It's just that you would need to know how to use that, how to leverage that, and how to bring that into your own organization. And that's exactly what we're going to talk about next. So first things first, in order to leverage and utilize data that is available online, it is generally a good idea to first look at the way that it's going to be consumed. So for instance, data sets are made available in different formats, and that can be in the form of CSVs or XMLs or JSON accordingly. And in all data programming languages, it's relatively straightforward to download these kinds of files from the internet. And that's what I'm going to show you in the lab today. In order to do this, and you will see this at the bottom of the slide, there are generally two steps required. The first step is that you would need to know where to retrieve the data from. And in almost all cases, that is through connecting to a specific URL that contains the data so that you can download that data set either to your local environment or to scrape the data of the website itself. And then the second thing that you need to do is specify some kind of an operation with which you can retrieve the data set from that particular URL. This two-step process is, I would say, very basic in terms of its operation, but no matter which kind of data set you're looking at, it generally works in exactly the same way, regardless of the structure. Why the structure is important, we're going to see in the example in a second, but this is the general two-step process that you would need to follow. Good, let's look at that a little bit more in detail. So if you don't have a programming background, don't worry. This is just some very, very simple code, but I also already would like to have the participants who have a bit more coding experience become familiar with the operations itself. And as you know, from the big data framework point of view, we're trying to be as vendor independent as possible. So I've listed both operations, both from an R perspective as well as a Python perspective. In the lab that I'm going to show you next, I'm going to be using a Python script just because it's my preferred language. But note that you could do the exact same thing within R. And basically what I wanted to show you right here is that the process is very similar regardless of the programming language that you're choosing, and follows that two-step approach that we just talked about. So the first thing that is typically done is that we are retrieving the URL. And what we're doing right here is that we are just saving that URL as a string into the URL variable. Then the second key point, as soon as we know where that URL resides, is that we need to specify what we're going to be doing with that data set. And for the sake of simplicity for today, I have just made a very simple script that explains to you that you can download that file towards a local folder. And in this case, it is going to be saved in a path of your choice. So this is obviously something that you would need to adjust with your own computer part. And that is where the data will subsequently be saved. So in this case, the data set that we're looking into is actually a CSV file. And this is where how the data that resides online is automatically going to be saved in a folder of your choice. And even if you do that on a daily basis, that specific folder is going to be refreshed with the specific new or updated file. Same is true on the right-hand side. Here we are going to get the URL and then open the file with the specific name and allow a redirect to it. What we're doing on the right-hand side is a slightly different example, because here we're not saving a CSV. Here we're actually saving the icon, which is part of the Big Data Framework website. And this an icon is actually a picture. So we are downloading this specific picture from the website. So two kind of different use cases, but the main idea is actually the same. Many people don't realize that this is all possible with running very, very simple scripts. So what is available on websites and online can in many cases be retrieved by using these very, very simple requests. So this is a bit of background in both programming languages so that you have a bit of a familiarity of how to do this. In the lab that we're going to show you next is we're obviously going to go through this a little bit more in detail. Good. So now that you know the basic structure, let me also explain the two most common semi-structured data formats with which you typically build a connection towards online data sources. And there is, in my opinion, two data structures that you will definitely need to know forward and backwards, because if you want to work with data that resides online, and this typically also includes application data, then XML and JSON are going to be, in most cases, the data structure or data format of choice. XML is a format that is very frequently used in internet applications. It looks very similar to HTML because it has all the tags as well. And it's very popular and very commonly used in a lot of different APIs because of its lightweight format and the fact that you can very easily connect with this. XML stands for Extendable Markup Language, and the main reason why it's called this way is obviously because all the text and the content itself is going to have markup around it. And markup are the labels with which we indicate what kind of category specific data actually is. And a good example is what we can see here on the right-hand side. So here we have a bookstore, and within that bookstore there are different book categories, and then each specific category will consist of a number of entries, and each of the books is indicated, or the specific content is created, the structure of the content is created by the specific markup tags. So for instance, here we see that the title is put between tags. And in this case, the title of the book is obviously Harry Potter, and the author is J.K. Rowling, who actually wrote the book. So even if you don't have any computer programming knowledge, or you're looking at data ingestion for the first time today, it's very straightforward and easy to kind of read what is happening right here. And that's one of the main benefits of XML. If you need to kind of go through it, it's relatively easy to understand because it just follows this neat format and this neat nesting. So that's why this is relatively important. So this is the first main language or data structure that you would need to know. The other one is obviously JSON, which is JavaScript Object Notation, as probably an even more popular format than XML. And it's used in a lot of the more commercial APIs. So if you want to analyze data from, let's say, social media providers, think about Facebook, X, or other kind of platforms, you will generally connect through an API and then have access towards a JSON stream. And the syntax in JSON is structured around key value pairs, or name value pairs, I should say, which means that it's going to be comma separated and between curly braces. In the demo that I'm going to show you today, I also have prepared a very simple JSON example, so you will become a little bit more familiar with this. But this is a slightly more advanced topic, which I thought would be maybe one step too far for a 30-minute webinar. But note that this is also something that you would generally need to do when it comes towards interacting and pulling data, especially from the internet. Good. So these are some of the main elements that we are going to look at. I always think it's better to see in practice how this works by yourself. So I prepared a small lab for you today so that you can follow along and see how you can extract these data sets from specific locations. So let's have a look at that. Good. Can I get a quick thumbs up if people are able to see the screen? Perfect. Very good. Thanks so much. So what I've prepared for you today, and we will obviously share the link towards this lab afterwards, is a very basic and simple lab in Google Colab, so that you have an understanding of, or can get a better understanding of, how do you download data directly from the internet? How do you deal with XML and JSON files, which I just explained in the lecture? And the last part is, how do you connect to databases? I have blocked that out for today because of time constraints, but those are generally the main things that we do in these particular exercises. So as a very simple example, what I thought to do today is to kind of give you some background from one of those open data sets, which I also showed you earlier in the slides today. So the main reason why we would like to use an application in order to retrieve data from online data sets is because in many cases, this is an operation that needs to be repeated over and over again. Think about stock market or social media messages. Those are being refreshed on a continual basis. So if you were to need to download that every time manually, step by step, that's going to be very, very time consuming, and especially can lead towards a lot of errors. So what we're going to do today is I'm going to show you how you can directly extract data from the internet. And in this case, I've selected an open data set from the open data website of the US government. And in this data set, what we're going to be looking at is cars. And especially the number of electric cars, the number of hybrid electric cars in a specific state in the US. And the link to the full data set can be found right here. So you will, let me very quickly show you this. So here is the original data set. We will see that it redirects us to data.gov. And this data set shows the electric vehicles in Washington State for a particular year. Good. So let's look at that. So what we could obviously do is we could go towards this site and then download the data set and then upload it again when we need it. But what I'm going to show you next is how you do that much quicker and have the ability to download that kind of right away. So in order to do this, we follow a very, very simple command. We download the libraries, and if you're unfamiliar with libraries, I recommend that you watch the previous webinar that we gave, in which we gave a full explanation around that. And in this case, we're going to be looking at the CSV file of this data set. So very, very simply going to run it. And it's just going to read the data directly from the website, in this case, this website, this URL, and then put that into a pandas data frame. And that's exactly what you see happening right here. It needs to reconnect a little bit because I have been presenting for a while. So let's give it a moment to do that. And as soon as that's done, it's going to show me the check mark. And that means that basically per direct, and it took less than half a minute, I now have access to the same data that is stored on this website. So even if I have no idea what kind of data is located there, or I have no clue on the contents of this data, with this very, very simple command, I have now made a connection towards this online data set. And every time that I hit this button, even if the data is being updated, then I am pulling a new set of data into my local environment. And I now have it available as a data frame in my own environment itself. So to kind of show you this, we can very simply run the data frame itself, and it will show you all the rows and columns that are part of this data set. So let's look at the bottom. So in this case, we have 153,000 rows and 17 different columns. So another key thing that I really would like you to notice and see is the speed and with which this is done, because we are downloading and using this within 26 seconds. And we're talking about a data set that has over 153,000 rows. So it's done very, very quickly, and this is highly, highly efficient. So notice the different parts. It's a large data set. You can actually see that it has been updated since the last time I ran this, because in my previous part lab, it was still 124,000 rows, and it's now updated to 153. So let me change that right away. And we still have 17 columns. So very interesting data, lots of data. So what I'm going to do next is basically show you some very basic breakdown. Today is not going to be around data analysis and data visualization, but I kind of wanted to show you some nice elements that you could do with this. So what we're basically doing right here is we're going to be looking at the year, the model year, and then we're going to be looking at the kind specifically and making a count of this. So you can see that electrical vehicles continue to become more popular. And in 2023, there were obviously way more sold than in the years before it. So in case you are wondering how market share is progressing, I think this data shows it to you very, very quickly. Also, will already has some data for 2024, so that's something that you would need to look into to see what that or why that is specifically happening. Good. So again, if you are if you're in the car business, if you are providing batteries, if you are a company that provides charging stations, then this public data, which is again very accurate, we're still in 2023, the data is already there. We go towards the website itself, you see that the latest update of this data set was on October 20th, 2023. So that's this week. So by just reading this data in, I instantly have access to the latest information. And that's the power of using these kinds of online tools. So hope that is clear. This is a relatively simple CSV, and I hope that you see that basically with just 2 lines of code, I have now connected and extracted data from this open set, which I could use to my benefit. And that's one of the main objectives that we have for the webinar today, is to kind of show you how quickly and how easily this is done. Good. For those of you who want to take it one step deeper, I also have some examples of how do you read JSON and XML files. And I'm going to start with JSON in this case, because it's a very popular data format. And what we do in this case is use a specific data set that's built in the sample data library from Google. And the reason I did that is just to kind of show you how it works. What this is doing is giving you data with statistical properties, which is a very famous pair within data science and mathematics. and it's going to show you the same mean, median, and mode, despite the fact that these have very different distributions. So if you do this, you're going to be able, with the pandas read JSON object, to import JSON in the same structure. And even though it is given in key value pairs, you can very easily translate that towards a tabular format. And that's exactly what you see right over here. So here we have these data sets imported. So the way to deal with JSON files is to basically use the exact same command right here, even if it's online. And instead of putting this built-in function, you can change it with any URL that is using JSON as their primary format. Good. Then last but not least, I'm going to do the last exercise a little bit quickly because I see that we're almost out of time, is that we need to have the same commands in order to read XML file. And what I've done here today is that I've also put the data from a specific link. And in this case, we are downloading zip codes in New York City from, again, the same data catalog in the US. So demographic statistics by zip code. And what we're doing right here is that we read that again within the part. And I see that I need to update this specific line. And this is going to then give us an overview of that specific demographics part. And specifically here, I filtered it on the data of the city of New York. So it gives you an overview of all of the specific demographic information by zip code. So with that, I hope that in a very short period of time, I've given you some of the 3 most common approaches with which you can download data sets from online resources. Let me go back towards the slides. Great. So just to wrap up a little bit, and before we move towards the Q&A. So hopefully in this very short 45 minutes, I've inspired you a little bit to learn more about this and to understand how easy and useful it is to learn more about this. So if you're thinking right now, what could we do next? Then here is my key pieces of advice. So first things first is, a lot of the things that I've been talking about today is available free of charge. So make use of that opportunity, download the free guides. They're all available on the Big Data Framework websites, and you can find them very easily. The main topic that I've been discussing today is coming out of the Enterprise Big Data Analyst Guide. So it's more around data analysis and slightly more advanced than the professional level, which is the entry level. So if you want to learn more about data ingestion, go download the Analyst Guide because that provides more detail. In case you would like to make a career out of this, or you're interested in becoming more knowledgeable around that, then I strongly recommend to look into the certification program. We've partnered with APMG International to build what is slowly becoming the leading certification program in enterprise big data. So this is a great place to kind of start building your credentials in a step-by-step manner. The big data program starts very simple, but takes steps to teach people how to become enterprise big data scientists and have, I would say, beyond basic a level of knowledge within that domain. Other key things that you could do is listen to the podcast, which I mentioned all the way at the start, or sign up for the next version of Big Data Days. Our next edition is going to come in 2024 because this year's conference has already passed. But the recordings of all the speakers that have been participating are still available online. So in case you're interested in that, you can watch them back and listen to the recordings on YouTube. Start learning today. So as I mentioned, the main program that we have been talking about today is coming out of the analyst level, which is the intermediary or practitioner level. And this is the level where you really need to kind of roll your sleeves up and get started with analyzing data on a daily basis. Good. Other key things that you could do is become a member. Our member community is growing every single year, and it gives you a great opportunity to network with some of the leading minds or the aspiring minds in the data science and big data community. And within that same portal, you can find a lot of resources. You can sign up for the courses, and you can become start on a journey to become better and better every single day. With that, I would like to spend a quick minute to see if there are any questions around the session today before we are moving towards a wrap-up. Let me see if there are any questions in the chat. I don't see any questions coming in. Might be something to do with the fact that it's Friday, last hour of the day. Good. If there are no questions, then we're going to slowly move towards a wrap-up. I would like to really thank you for taking the time to tune in with us again today. In case you would like to get into contact, all our contact details are here on the slide, and we will send out a copy of this slide to everyone who has participated within the session today, as well as a link to the lab, so you can practice with these by yourself. Thanks again for taking the time to be with us today, and I hope to see you again in the future anytime soon.